And then lastly, I'm sure I must only have a few minutes left, I thought I would give you an example of the type of research activity that we're investing in. This I regard as, I think it's really beautiful. It's a bunch of pipe works for an advanced gas-cooled reactor, and in particular, issues down here with the splitting here of this pipe. It's called a bifurcation, and what happens is, at that bifurcation, just adjacent to the weld, the residual stress causes a cracking issue. So that's the actual weld material. No, that's the weld parent material. The residual stress due to the weld causes the stress corrosion cracking to occur just there. Which means that you have to shut your reactors down. Which means you lose £1 million a day. And you'll be surprised to know that they turned to this building here, which is the neutron spallation source at Harwell. That, by the way, is not a nuclear power station. That is Didcot, conventional power station. And in fact, more radiation is released from the carbon-14 released from the burning of the coal. Actually, it's just shut down, as a matter of fact, there than has ever been released from these nuclear facilities here. They have something called Engine X, which looks at uses neutron diffraction to look at residual stresses. And the question is, what kind of heat treatments do you need to use to remove the residual stresses so that you can just re-weld it and off you go? So there's a mock-up of the bifurcation. So that's the weld material. You can look at the neutron diffraction. It tells you what the stress distributions are. You can then do certain heat treatments to remove those that type of distribution of residual stress, and you can use modelling, finite element modelling then, to make those sorts of predictions. So you have neutron diffraction, you have modelling, you have the basic science associated with residual stress to solve a very, very practical issue in the nuclear arena. That is what's going to really make a difference to us, that kind of activity. I've got some other examples here on zirconium alloys. Here is a crack in graphite. I talked about that earlier on, since James Marrow's work in Oxford. That's what a typical radiograph would look like. We can now do three-dimensional radiographic analysis, and to actually really start to look at what those crack processes look like and understand whether or not they are significant to the operation of the reactor or not. Again, using really advanced research techniques to look at proper engineering issues.